you guys were at this moment.
No, I appreciate that. I had actually completely forgotten that we were supposed to record this meeting. So, to all attendees, we don't typically record these Las Posas Valley TAC meetings. We are recording today's meeting because Dr. Bob Abrams was not able to attend. He had a prearranged vacation planned. But the presentation that we're going to receive today is important for him to be able to review, and we wanted to have him give him the ability to review the presentation as it was provided by Intera. So we are reviewing this meeting. A copy of the recording will be posted to the Watermaster website for public review. The recording is started. Anyone who wishes to opt out, feel free to leave the meeting. Sorry. Thank you. Thank you, Farai, for bringing that forward. Appreciate that. We go back to our regular agenda now and ask if there are any public comments on the minutes from our last meeting. I am not seeing any, so I'm going to assume that the meeting minutes are good as they are and see if Tony can give us a motion to accept the meeting minutes.
So moved.
Seconded. All in favor? Aye.
Aye.
Thank you. All right, we're ready to move into our main item for today's meeting, which is a presentation from Intera on the modifications to the East Las Posas management area model. Brian, who is giving the presentation? Who should I promote to panelists so they can share?
Why don't you promote both Trevor and Tyler? Trevor's going to be doing the presentation, but Tyler's been involved, and it'd be good for him to be able to answer questions as well. Then I'll give a preface when we're ready.
Okay, I think Dr. Jones and Dr. Hatch are both on and ready to go. So, Brian, take it away.
Yeah, thanks, Chad, and Fox Canyon Water Master staff for allowing the schedule to be modified so that we could do this. I think you'll find this presentation very helpful. Just as a reminder for maybe the public or those, my name is Brian Bundy. I'm Cayugas's representative on the TAC. I've been involved with this model since the beginning. Originally, when I was an employee at Cayugas, I was the groundwater manager, and I was involved with starting this process and was very involved with the technical work that led to this model. And then now later as a consultant, I remain involved. And Intera has been working with me to develop and update this model. We started this process over a decade ago. And what you're going to hear about today is just the latest updates in terms of continually improving the model for its use. And I hope that you find the information very informative. And we ask that please ask any and all questions. There's no dumb questions. We're here to help everybody understand. The background for this is that as per the judgment, there's something called the ASR study group that's called for. That study group is comprised of Dr. Abrams, myself, and Rob Hampson, who I see online in the participant side of this meeting. We are a committee that's charged with coming up with an operations plan for the operation of Cayugas's aquifer storage and recovery project. This is all called for in the judgment. And that process is going to necessarily require some modeling to look at how the ASR operations affect groundwater levels and users in the basin. And so the study group asked Watermaster to have TAC review the latest updates to the model, which are documented in a technical memorandum and will be summarized in the presentation. The reason we asked for TAC to review that is because TAC also has a role in reviewing the ultimate ASR operations plan that comes out of the study group. So we felt it was more than logical, if we're going to be using the model, to get any and all feedback before we do the modeling from TAC, as opposed to sending them a plan and an updated model and say, here it is. So that's why we're here. And Watermaster is also interested in TAC's feedback on the updates to the model with respect to just broader East Las Posas management issues. So those are the two focus areas of the TAC review. I think with that, I'll hand it over to Trevor to go through the updates that we've been working on.
Great. Thank you, Brian. Good afternoon, members of the TAC. Let me see if I can share this screen correctly and then jump into. All right, how is that? You guys seeing full screen presentation mode okay?
Yeah, we're seeing it.
Awesome.
Yeah. Yes.
Great. Well, thanks, Brian, for the intro and for setting the stage here. Again, my name is Trevor Jones. I'm a senior water resources engineer here at Intera, and I'll be walking through at a high level the work we've completed to support Cayugas's update of the East Las Posas model. We have structured the discussion today to be broken down into kind of 5 different sections, really starting with an overview of how the model has been used and was developed for the East Las Posas management area, walking through the broader recalibration efforts that are described in this tech memo. And to get us there, we'll touch on a lot of the new data and information that have been collected in the basin since development of the model, how that was integrated into an extension, validated, and then used to inform some structural revisions that, again, ultimately led to this recalibration effort. And I think what you'll find throughout this presentation and in the tech memo is that there are some key areas of improvement in the model that have resulted from Cayugas's recent efforts. The first being an improved representation of how the Fox and Grimes Canyon aquifers are represented in the model based on, again, additional geophysical data and well completion report data that were evaluated in this process. And then from a model performance standpoint, you'll see an improved simulation of just general groundwater elevations and their trends across the basin, as well as groundwater elevation responses to ASR operational events. So those will be the 3 key pieces that I think we're going to touch on today and are really highlighted in the technical memorandum. Before we get there, though, we wanted to, again, just kind of lay the foundation for how the model has been used and was developed, and what motivated this most recent update of the East Las Posas model. This dates really back starting in around the 2015 timeframe, where Cayugas undertook efforts to develop the initial model to both support their ASR operations as well as broader management activities and planning for the basin itself. That version of the model, which I'm going to refer to throughout this as the original East Las Posas model, it was calibrated for the period from 1970 through 2015. And to support its use in the GSP, the model underwent a couple rounds of review, first by the GSP's Technical Advisory Group, or TAG, at the time, which led to some interim refinements of the model prior to use for the GSP. And secondly, that the original model was independently reviewed by Dudek and Stanford to quantify uncertainty in the model and evaluate its suitability for the GSP. As the TAC is familiar, this model was used for the GSP to both develop historical groundwater budgets, as well as project and evaluate future conditions in East Las Posas over the GSP implementation horizon. After the GSP, where we have this little diamond marker on our timeline, Cayugas handed the model over to Fox Canyon, where they've been using it to support development of the periodic evaluation and the basin optimization yield study. The version of the model that supported those efforts really is the same structurally as that original East Las Posas model, with a few years tacked on to the simulation period for the periodic evaluation to evaluate performance through, I believe, 2022. Along a similar trajectory, though, Cayugas has continued to update and maintain the model. The technical memorandum that was provided to the TAC documents both of those phases of model updates. We'll touch briefly on phase 1 of the updates in the next slide, and then spend most of our time in what we refer to in the tech memo as phase 2 updates. what we are referring to as phase one updates of the model really were undertaken to address some areas identified during the model's use for the GSP as areas of improvement for the model. Those two key areas were how the Happy Camp Canyon area was represented in the model. That is, if you can see my cursor, this shaded gray area in the northeastern part of the valley. And then the second component that was updated were the components of return flows that were represented in the model recharge package. In the Happy Camp Canyon area, the large structural change was a chunk of the Grimes Canyon aquifer that was originally represented in the active model domain was removed from the model. The reason it was removed from the model is largely because there was very little data, if not any data, that was available to constrain how the model represented that portion of the aquifer. And as a result of that limited data, heads were building up in that eastern part of the model domain and causing groundwater levels to rise above land surface, again, unconstrained by any groundwater elevation measurements or well log data that could characterize the region. So what Kaygas did was they removed that part of the model and replaced it with a fixed flux boundary condition to both just get rid of that uncertain part of how the model was being represented and address the flooding issues that were identified during use of the model for the GSP. The second component was the addition of 3 separate recharge terms in the recharge package. There was the addition of septic system return flows, M&I return flows, and distribution system leakages. Those were added to the recharge package and applied specifically to the areas of the Epworth gravels and the shallow alluvial aquifer. These minor revisions were done to just for completeness and consistency across east and west Las Posas. As part of that, though, the model was slightly recalibrated to ensure that performance was commensurate with the version of the model, that original version of the model that was used for the GSP. What we're going to talk about, though, is taking that end product of phase one updates and using that for the broader East Las Posas model update that's described in much more detail in the technical memorandum. We're going to spend the next few slides talking specifically about the new data and information that was used to constrain the update, how that was integrated into the model to extend it, how that extension period was used to evaluate or validate model performance, and then how that led into the decision to update and recalibrate the model. But really the story starts with the quality and quantity of data that are now available for the model for recalibration and calibration purposes. And a lot of that is built on the monitoring network that Kaygas has been building out since really 2010, where they have equipped a number of wells across Las Posas with high frequency pressure transducers. The location of those monitoring wells equipped with transducers are shown here in this map in red. In addition to maintaining transducers throughout Las Posas, they've constructed 5 shallow monitoring wells along Arroyo Simi Las Posas, and have constructed 3 separate depth discrete monitoring wells in East Las Posas, 2 of which are nested and 1 which is clustered. And while Kaygas was building this network out, really starting in 2010, the majority of this data were not available to calibrate the original version of the model through 2015. So what you'll see in the set of hydrographs and the calibration information that we present later is that these high frequency data and the construction of these new monitoring wells significantly enhances the number and quality of groundwater level data that are used to constrain the model. So there's first point on new data is a significant improvement in the type and quality of groundwater level data for modeling. The second was in 2022, Kaygas implemented their emergency imported water recovery operational event, over which about a 4.5-month period, Kaygas recovered about 4,000 acre feet of water from East Las Posas. And why this is important from a model standpoint is because Kaigas was operating their monitoring network that was equipped with high frequency data loggers. So during the recovery event, there's high fidelity information on and ability to characterize how the aquifers are responding to ASR operations during that period. So you'll see, for example, this chart will show up a lot when we talk about model performance because we have a good sense of how the aquifer is responding to ASR recovery during this 2022 period. So we have all of this new information. Again, it's important and good information. The first step that was taken was to just extend the model. So going from 2015, extending it out through the end of March 2023. The way that extension was implemented was through 2021. The model uses a monthly stress period. That's the same temporal discretization that the original model used. But in 2022, the model switches to a daily stress period. The reason behind the switch from monthly to daily was, again, to be able to integrate all of the information that was collected by Kaigas during their emergency imported water recovery operational event. So we've got, again, the majority of the simulation period is monthly. In 2022, when there's a lot of high frequency groundwater level data and ASR wellfield operation data, the model uses a daily stress period. From the boundary condition side of things, the majority of the boundary conditions still use constant monthly fluxes. This is consistent with the original model design. The one variant is in how pumping is represented. For non-ASR wells, the same approach is used to represent pumping on a monthly basis based on FCGMA semi-annual extractions reporting. But when the model transitions to daily stress period, the net daily ASR operations are implemented into the well package rather than using a constant monthly flux term at those ASR wells. So again, just integrating the high frequency data that we have available at our hands. We're going to jump now into a discussion of model performance for just the extended model, not the recalibrated, but prior to recalibrating, we extend the model and evaluate how the model performs. Before we go through that, I just want to pause here and just kind of discuss how we're going to present these results and how they're presented in the tech memo. We really focus on kind of this geographic discussion, this difference between the southern part of the ELPMA and the northern part of the ELPMA and the relationship to the Moore-Park anticline, which provides limits flow from south to north and has contributed to groundwater level declines in northern ELPMA. So we're going to start in the south, where since the 1970s, really, that portion of the aquifer is filled and groundwater levels have stayed high. The key takeaways you're going to see from this part of the model validation, of validating the extended model, is we're going to focus specifically on the post-2015 period. So this chart in the upper part of the model, in the upper part of the slide, really focuses in on a hydrograph. Post-2015 is everything extension, so not calibrated, just extending the model and comparing how the model results or simulation results shown with the solid black line compared to the observed groundwater levels shown in blue. The key takeaways here are that regionally, heads in the northern ELPMA, what we saw from the model results are generally high. So the model tends to overestimate those heads. And then you'll see an opportunity to improve the model's simulation of ASR, of groundwater level fluctuations during the ASR operations. And one thing to note is that this bias high was recognized and has been acknowledged. You'll see it show up in both the GSP and periodic evaluation, where simulation results in the north are shifted down to better represent measured groundwater levels. We're going to start, oops, I didn't know there was animations on there. We're going to start in the southern ELPMA. What we're showing here again, we're looking specifically at the extended model. Observations on these charts are shown with the blue markers and simulations are shown with the black solid lines. The key here is in the southern ELPMA, the original extended model has performed similarly well. So generally reproduces the filling and the maintenance of those water levels throughout the extension period. As we move north, though, that story tends to change a little bit. Here, the simulated and measured hydrographs in this four-pane graphic correspond to these four wells highlighted with the green markers in the inset map. In this part of the model domain, which is right in Cayugas' ASR well field, what we see from the model results is that the temporal patterns in water level changes are well represented with the model, but the model tends to overestimate those heads. So specifically, if we look at 31 DO7, the patterns are well matched, but there's just this 15-foot offset high in the simulated heads that persist throughout the period. If we move farther north again, I'm going to start here with these blue markers, 30 EO7 and 30 DO1. Before we talk about model performance here, the one thing I want to point out is the date range of the groundwater levels that have been measured at these wells. Most of the groundwater level measurements collected here are post 2015. Again, and that 2015 threshold is the original model calibration period. So what these two wells represent are new data points for the model in terms of an area to constrain that wasn't originally available during the model design. In these two wells, the extended model tends to not capture the temporal patterns very well. It's generally at 30 EO7, kind of a flat line, doesn't capture the declines in 2022 that well. And 30 DO1 simulation results are generally high. And again, those temporal patterns are not very well represented. But then when we move south of the Fairview Fault, which I haven't specifically called out, but it's this solid black line that separates the green markers from the blue markers, we see similar results that we saw in the ASR well field. Temporal patterns are well represented, but the simulation results tend to be high compared to the measured data. And then the last key component we want to highlight before we talk about the recalibration is that in addition to looking at those general patterns in groundwater levels, we did evaluate how the model performed during Cayugas' emergency imported water recovery operational event. Here we've grabbed one of those hydrographs from the last slide just to highlight this period of groundwater level decline during the recovery event. And to demonstrate that extended model did not capture those declines well. So there was an obvious area for improvement in how the model represents aquifer responses to ASR operations. So after the model was extended, the first thing that Cayugas did was try to ask the question, can some localized parameter adjustments be implemented to better match those observations? And what we found was that the parameter adjustments that were required to match those heads just were not consistent with the HCM. So that led Cayugas to reevaluate the structural representation of the Fox and Grimes Canyon aquifer. Those evaluations were focused on two key areas, areas north of the Fairview Fault and along the Moore Park anticline. The structural refinements, the key goals were to, one, integrate new information, both from a geophysical and lithologic standpoint that were collected at Cayugas' new monitoring wells. Those are both in the north of the Fairview Fault area and along the Moore Park anticline. And then north of the Fairview Fault, the intent was also to better represent the groundwater conditions within the Fox Canyon aquifer and the transition from semi-confined to confined. And because of that, the decision was made to split the Fox Canyon aquifer into two model layers. That split and those revisions to the model layering were based on our review of geophysical logs, well construction, and groundwater level data from at more than 80 wells. The graphics that are shown here on this slide come directly from an appendix of the TAC memo that present the geophysical data that we reviewed and how that informed updated interpretation of the top and bottom elevations of the Fox Canyon aquifer, as well as where that aquifer can be split into two separate layers. That split into two separate layers is also consistent with United's observations of two distinct units of the Fox Canyon Aquifer and the OPV basin. So this conversion from 1 to 2, again, is based on 1 to 2 layers is based on geophysical data and is also consistent with how it's represented in adjacent basins. At the end of the day, what this resulted in is in the northern part of the East Los Pozos Management Area, north of the Fairview Fault, the reinterpreted Fox Canyon Aquifer is deeper and thicker than previously represented in the last version, in the original model. And in the along the Moore Park anticline, the Fox Canyon Aquifer is generally shallower than previously interpreted. And these graphics are pulled directly from the technical memorandum. So we have, to summarize again and just pause before we get into more data, what we've presented so far is that there's been a significant amount of data that have been collected in the basin. The extended model tended to overestimate or slightly biased high compared to measurements. And there was an opportunity to improve how the model represented ASR responses. And we had improvements to how the model was designed structurally from a model layer and aquifer standpoint. Given all of that, there was then the decision to recalibrate the model from a more holistic standpoint. Rather than focusing on localized areas of parameter adjustments, there was a broader effort to recalibrate the East Los Pozos model. What we want to highlight here is, in addition to the past few slides, and really to emphasize the amount of data that was available for this, this table that we have on the right-hand side of the screen comes directly from the tech memo. And if we look at the total number of measurements from 2016 through 2023, that more than doubles the number of groundwater levels that were available to constrain the model compared to the original model development. So there's, again, just a large number of data with an improved frequency that are used to can be used to characterize how the model represents groundwater conditions in East Los Pozos. The approach to recalibrating, slightly different than the original model development as well. This recalibration effort utilized the parameter estimation software PEST. Within that PEST software, there is a global optimization method called the Iterative Ensemble Kalman Smoother. It's a global optimization method that accounts for uncertainty in parameters and uncertainty in predictions. This method was used to reparameterize exclusively the Fox Canyon Aquifer and Grimes Canyon Aquifer. So there was a focus specifically on revising the aquifer properties and the structural features in those two aquifer units. The Upper San Pedro, shallow alluvial aquifer, and Epworth gravels were not modified during the calibration effort. Model calibration was evaluated using both qualitative and quantitative metrics. Qualitatively, kind of the standard visual observation of how well the model matches trends, and quantitatively from looking at the correlation between model measurements and looking at global residuals to ensure that the recalibration was commensurate with, if not improving on, the previous model version. We're going to jump through south to north again, same set of hydrographs. Here, these hydrographs are pulled from an appendix of the TM. What we want to highlight here is trajectories or performance is commensurate with the original model version. Again, so in the southern ELPMA, where the aquifer is progressively filled, the updated and recalibrated model performs equally well. As we move north, this is where we start to see the largest improvements. Here we're now showing two different simulation traces. In red, we have the original extended model. In black, we have the recalibrated model. Observations are still shown with the blue markers. What we see is, specifically, if we hone in, the data is cleanest at 31 D07. The recalibrated model in black follows the temporal patterns of those water level measurements well. What's been improved on specifically is that overestimation of heads. So we see a better match in the general, the average groundwater level and groundwater level drawdown throughout the record at this well. And we've quantified that in each of these graphics through this root mean square error metric here, where we see about a 10-foot improvement in the overestimation bias. Same set of hydrographs as well as we move north, starting with the blue wells, 30 EO7, 30 DO1. At both wells, the model better matches observations, again, quantified through this root mean square metric. Specifically at 30 DO1, not only do we see a better match of the temporal patterns, but in 2022, we see a better representation of those drawdowns or groundwater level declines, I should say. Same thing when we move to these green markers, 25 RO4 and 36 AO2, the updated model, again, matches the temporal patterns well and shifts those simulated heads lower to better represent the observations at these wells. As I was mentioning last slide, one of these key areas of improvements was how the model represented groundwater level fluctuations during the recovery event in 2022. Here, the black updated recalibrated model trajectory more closely matches the measured groundwater level declines when compared to the red extended model. So there's a significant improvement in how the model represents these ASR responses across the basin. So what we've just walked through are a couple of individual hydrographs. We have a much larger set of hydrographs for all of our calibration wells in the technical memorandum that are included in the appendix. What we want to note on here, though, is that when we look at things globally, so model-wide, and not just every aquifer individually or every aquifer together, but also as we look at these aquifer statistics individually, the model is performing well. When we look at the normalized residuals, which are just, for example, the root mean square error values normalized by the range of observed water levels, we're falling between 2 and 4% of those ranges as our model error, which is commensurate with the original model, if not slightly improved. And when we look at the relationship between measured groundwater elevations shown in this chart and simulated groundwater elevations, those that relationship follows closely this one-to-one line, which is shown with the gray dashed line, which indicates there's no evidence of structural bias where those would be deviating from the one-to-one line significantly. What was done, you'll see we have appendices in the updated TM with updated aquifer properties from both the storage standpoint, conductivity, and fault conductance standpoint. Summarized here, largely what was done, what PEST implemented from a parameter adjustment standpoint was higher hydraulic conductivities north of the Fairview Fault, a lot more heterogeneity in the storage properties. And then kind of the larger change, important change, is the increase in conductance of the Fairview Fault and more park anticline to allow that ASR signal to propagate north during the recovery event. So where does this land us all? This is the last slide. You guys get to stop hearing me talking for a little bit now, but Kaigas extended the model, went through a validation exercise, and identified specific areas for improvement of the model. That led to some structural refinements of how the Fox and Grimes Canyon aquifers are represented. And importantly, the Fox Canyon aquifer was split into 2 model layers. From a performance standpoint, the model was recalibrated with PEST. And as a result of the recalibration, the model now tends to better match groundwater elevations and trends and better improve the model's representation of ASR responses across these lost poses. And with that, I don't have a question slide, but I will pause here. I'm happy to take any questions.
Thank you, Trevor.
Absolutely.
Members of the TAC, or your ready for questions? I'll get us started. I think I just want to confirm the parameters that were changed during calibration were just aquifer parameters, including the fault hydraulic conditions. You didn't
Correct.
change any recharge,
No.
discharge
Correct.
components. Yeah. Okay. It's impressive that you were able to get the match, especially on those newer data sets with
Mhm.
the calibration. Good job.
A nice job improving the model. If you had another 6 months and an unlimited budget, what would you do to the model?
That's a hard question. Um, Probably take a fresh look at the hydrographs and look in the, you'll see in some of our comparative hydrographs in the tech memo in the Southern ELPMA at Cayugas's new clustered well. I think there's still some areas for improvement there. We look at the how the model represents groundwater conditions in that specific area.
Mhm.
So do you think that's the weakest area for in the model currently?
I think there are areas for improvement. I Weakest area of the model, I don't know. I think there are areas for improvement in that
Yeah.
part of the model.
Trevor, maybe you could show that on a map.
Yeah. We're talking like right well, I have this well here, purple. It's very, you have to squint to see it. Um, New monitoring well constructed by Cayugas south of the anticline. Um, Again, we call these hydrographs out specifically in the TM. We don't have them in slides, but yeah, there are opportunities for improvement.
Yeah, so this is Brian. So when we drilled that monitoring well, um, we encountered the Fox Canyon at a pretty shallow depth. Not too surprising because it's on the south limb of the anticline. But we also encountered some very hard black shale, which is probably the Santa Barbara Formation. So we didn't see what we thought was Grimes Canyon aquifer. Um, and we've been tracking the heads there in the three zones. And there's some interesting vertical gradients going on there. It's probably beyond the scope of today, but that's something we could provide more background on for discussion if TAC wants. But long way of saying it's it's complicated area structurally.
And I think that maybe Tony's question and mine also, this we've been asked by the water master to evaluate two things. One is how does the updated model appear to function for evaluation of ASR in the Cayugas ASR project? And then would the updated model be a good tool for use in doing predictive simulations for management of the wider basin? And so if there are areas that we should be considering have less predictive resolution when we are looking at other projects, we'd want to kind of identify those now. It sounds like that's the
Yeah, and I will say in the TM, what we do provide is as an appendix a table that quantifies, if I'm remembering right, well by well residuals as well as uncertainty in simulated heads. So that'll give you a sense of model match at those individual locations, and then where those uncertainty ranges are large, it's a location that's not well constrained from a parameter side of things.
great.
I'm going to
Other
jump back to
questions?
the summary. Oh,
Dr. Weinberger, do you have any questions on behalf of the Water Master?
No, I don't. I appreciate the thorough review and the model documentation on this. It's very helpful for being able to assess the model and all of the questions that you brought up around use for basin management planning.
Trevor, that portion of the model that was removed in the northeast, that specified flux boundary that you put in, how did you define those fluxes?
That is a good question. I would have to go back and review how that was dealt with.
Okay.
I don't know if Tyler's online and remembers, but that's something we can definitely pull together.
This is Tyler Hatch. I think that's an appendix, or sorry, attachment A, how that was done. But I think there was a bit of assumption based on some average values, and then there was some calibration involved in fine tuning what those were based on the previous knowledge of the ponding up in the Happy Camp Canyon, if I remember correctly.
Okay, thank you. Brian, I don't know that we ever managed to distribute attachment A to the TAC.
Well, Rob has it, and I asked for them internally to get it from Rob. So I guess that's a question for I or for Rob. They have it on their end.
Yeah, so for Ryan and Rob, if possible, it'd be probably good for the TAC to receive that attachment.
Mm-hmm.
Brian has it, and Bob may, but Tony and I don't.
Should be in that, Rob. It should be in that share file that you gave me a month or two ago.
Yeah, Rob typed in the chat that he can follow up on that. So thank you, Rob.
Oh, okay, great. Yeah, on that Happy Camp area, Chad, if I could just add, we originally included that area in the model because it's mapped as Fox Canyon shows it as the outcrop area of the aquifer. That area goes way out, way up that what's called Happy Camp Canyon, and it's, geologic map shows that there's units that could be interpreted as Fox Canyon out there. But there's no wells, so that indicates that either nobody tried to drill or there's no water out there. It's very thin. And so the reason we included it is because it's mapped as outcrop and for completeness. But in hindsight, had we known what we know now, we probably wouldn't have had it included to begin with, in case people are wondering why it got removed. It just ended up being a problem area with really no import to the whole analysis of anything.
Understood. Yeah. I'm sure we've all been in that position of having a vestigial limb of an aquifer that we wish we hadn't included.
Yeah.
Okay. TAC members, any other questions for Intera?
I always like to see a graphic summarizing the area, the error distributed across the basin, what areas are really spot on and what areas are high, what areas are low, and that kind of thing. And so that can be something that's used in the management decision-making process to say, hey, the water levels are predicted to be X over here. We know the model over predicts heads by 20 feet. So we need to factor that into our management conversations and considerations. So something like that kind of graphic, I think, would be helpful. I didn't see it in the tech memo, but it may be there and I just overlooked it.
I believe we have those for each aquifer in the
Okay.
tech memo.
Okay.
You're talking like a bubble map with
Yeah. Kind of a
spatial
bubble.
distribution. Yeah. Of
Yeah.
error. Yeah.
Yeah.
Yeah, they start on, I think it's figure 5.7. Right. Are those the ones you're referring to, Trevor?
Yeah, exactly.
Yeah, if you see something that you'd like to see, let us know and we'll see what we can do to provide if you don't see what you would like to see in the memo.
Okay, yeah, you got them in there. There, thank you. I just overlooked them.
Okay. Members of the public, any questions, comments for Intera that you'd like to bring to the TAC's attention? Hi, Mr. Pakala. You should be able to unmute yourself.
Can you hear me now?
Yes.
Yes. This is Reddy Pakala. I'm talking to you as a retired manager of Waterwork District Number 1 and also a resident of Moore Park. Just some observations and comments. So we have quite a bit of data for almost 45 years worth of data from 1970 to 2015 for this Fox Canyon aquifer. And this particular model, you guys have done a great job of taking all this data and you're updating this currently based on 2015 and 2019. And I'm happy to see this may be one of the basins we have such a great data and so much modeling work was done and we are refining them. And hopefully with all the work that you guys are doing with the TAC review, the people here would accept this modeling is great tool for us to plan for our future projects and also making sure that we have reliable water supply for Ventura County. I just have one observation and one question. So based on what I'm understanding is hydrologically east and west basins are two separate basins. And there's a minimal seepage between east and west Las Posas Basin. That's my understanding. If that's inaccurate, you can comment on it. And one question I have is how and where are the upper and shallow aquifers are connected?
I'm assuming that you mean between the east and west Las Posas management areas. What are the connections between the aquifer units?
No, my question is more related to Fox Canyon and Grams Canyon aquifer modeling we are talking about, where you have a shallow aquifer. It used to be called South Las Posas Basin, Epworth gravel. Now you are not using those words like South Las Posas. You're not using like analyzing Epworth gravel. My question is when I say shallow aquifer, I'm talking about South Las Posas Basin.
Yeah, I think I can answer that. Can we find a map, Trevor? Maybe.
Let me see. This might be the best kind of regional map we have, Brian, in the presentation.
Okay, so thanks for the question, Reddy. Yeah, so we of technical people in the GSA, the Fox Canyon Water Master don't refer to as South Las Posas anymore. The management of the basin has been characterized as just west and east. Within the east, what used to be referred to as the South Las Posas Basin is the area that's below the Moore Park anticline. Trevor, can you kind of show where the Moore Park anticline is? That's roughly kind of the northern limit of what used to be called the South Las Posas Basin. Within that area, you see the purple line, that's the Arroyo Las Posas. So we all still recognize that there's a shallow alluvial aquifer that's associated with that arroyo, that basically the shallow sediments that were deposited by that arroyo that can be, up to maybe 100 feet thick, plus or minus. So that's in the model and it's simulated with its own layer, as is the Epworth aquifer. And maybe Trevor, you could kind of circle up in the north where that is, kind of up north of that Fairview Fault along Broadway Avenue. That's simulated as its own layer, shallow layer in the model. So the Epworth and the shallow alluvium is accounted for in the model. I think the other question, Reddy, that you asked is where do the shallow units have the most hydrologic connectivity with the Fox Canyon Aquifer? That's where we found that looking at the well logs is down. Trevor, if you could, you know where that is, maybe a little bit further west, kind of circle that area. You see the big kink in the arroyo? A little bit further west.
Is that so, Brian? Is that close to the hydrological barrier between east and west Las Posas?
So you see the dark gray shading, that's indicating the East Las Posas area. And
Okay.
where the shading disappears, we have that green line.
Yes.
That's the boundary between the west and east. So where we were circling, that is an area where the Fox Canyon Aquifer is very shallow, and the low permeability sediments of what we call the Upper San Pedro Formation have been eroded away, and so the shallow aquifer is in direct communication with the Fox Canyon in that area, and that's where there's really good communication between the shallow aquifer and the Fox Canyon. Incidentally, just kind of a historical perspective on it, that's where Zone Mutual, which was formed way back turn of last century, cited all its wells, and that's for good reason because that area had prevalent water because of that geology. So it's been known for a long time, anecdotally, I guess, that that's the area where the shallow and the deep zones are connected.
Very good, very good. Yeah, thank you for answering that, Brian. Now I have a better understanding. Thank you very much.
You're welcome.
Great. Thank you, Reddy. Any other public comments, questions? Okay. Trevor and Tyler, thank you so much for your presentation. Congratulations on having an updated model that calibrates so well. I'm sure that feels like a relief. And we'll be deliberating over the next few meetings while we wait for Dr. Abrams to come back, and then we'll have a recommendation report to the TAC.
Thank you very much.
Yeah,
Thank you for joining us.
Thank you, guys.
Okay. I'm going to leave Trevor and Tyler as panelists. It feels like more work to remove them right now than just let them stay as panelists for the remainder of our meeting. We are on to item 3 on our agenda, and this is the kind of housekeeping things that we typically do. The first is an update on upcoming committee consultation review requests. And Jill, I don't know if you talked to Kim. We usually ask him if there's anything that we should know about that's coming to us and if there's dates for it.
Yeah, I apologize. I didn't actually connect with him on that
No worries.
before he left. I personally am not aware of anything that you're not also already aware of as far as moving parts on existing studies and things like that.
Okay, great. Thank you. Members of the public, or members of the TAC, any questions about that? I can't see how there would be. Members of the public, any comments, questions on our upcoming committee consultation review requests? Okay, not seeing any. If you think of one and you want to circle back in the few minutes that remain, we can do that. The next item on our agenda is the schedule for completing our current committee consultation requests and recommendation reports. We are, as just mentioned, reviewing the East Las Posas management area model update that we just received a presentation from Intera on. And we'll continue to do that over the course of the next few meetings while looking at you, Brian, and thinking about Bob. While Bob Abrams is on vacation, and then when he returns, we'll convene the entire group and finalize our review comments and get a recommendation report, I assume, together on this document. We're looking at June 5th, I think, was our scheduled date for delivery of a recommendation report. So we have few TAC meetings for deliberation, consideration of a recommendation report. We'll establish what the timeline for TAC, tabular, and other written comments for inclusion in the recommendation report will be once Dr. Abrams returns, but that's our general timeline. TAC members, any thoughts, new information from our last meeting on that schedule? Okay. Thank you. Members of the public, any comments, thoughts on the TAC's schedule for existing consultation? Okay, I'm not seeing any members of the TAC, any items for future agenda that we should plan to include? Okay, not seeing any members of the public. Anything you'd like the TAC to consider for future agenda? I'm not seeing anything, and if anyone comes up with something, feel free to send me a message. I think that's it for us. I'm going to make a motion that we adjourn at 3:02 p.m. Not quite an hour early, but plenty of time left in the period. Do you have a second?
A second.
Thank you, Tony. All in favor? Aye.
Aye.
Thank you all. Appreciate your time, and thank you again to Intera and Dr. Weinberger for joining us.
Take care.
Thanks a lot, everybody.
You too.
Everyone.
Bye.
Bye now.